Thank you so much for joining this lesson. We're going to handle mathematics section 1 of paper 2, and I hope you guys are going to benefit from this program. Remember to subscribe, remember to share so that you may invite a friend. So the section 1, which is a very good section, the first question is from a sequences and series. In a GP, that's a geometric progression, the sum of the second and the third term is 27, and the sum of the fifth and the sixth terms of the same series is 729. Calculate the common ratio and the first term of the series. We're supposed to know how nth terms are gotten for the different types of series. For example, nth term in a GP is usually given by the first term multiplied by the common ratio raised to the power of n minus 1. So the first term will be given by, it's the letter A, small letter A. The second shall be A times R raised to n. You see that? Then the third shall be A R power. That means n is 3. So 3 minus 1. Then we're also talking about the fifth. So the fifth term shall be A R power 4. Then finally, the sixth, which is A raised to R, or A multiplied by R, power n minus 1, that way. So there is something that we are told about these terms now. The second, the third, the fifth, and the sixth. So when we take the second term, remember that should be R power 1 minus 1, which is a 0. So we are talking about now the second term. When we take AR and we add the third, which is A R squared, we're supposed to get 27. That's the first equation. Again, when given the fifth, A R power 4 plus A R power 5, that is the sixth term, we're getting 729. This is our second equation. So we're supposed to solve these equations. And for us to solve them, we can take the ratios. Because it is a geometric sequence, then we can say, when we take A R power 4 plus A R power 5, we divide this by AR plus AR squared. We are supposed to get 729 over 27. Remember, when you divide this now, you're getting 27. And on my left-hand side, I'm supposed to talk about AR power 4 factored out to remain with 1 plus R. Divide by, in the denominator, I can factor out AR, again to remain with 1 plus R. So you discover that 1 plus R can simplify out that way. Once it is simplified out, now you say A can also cancel out. A can also cancel out like that. And 1 R cancels out, so that remains R power 3 is 27. So the value of R now is going to be the third root of 27, which is just 3. So the common ratio in this particular geometric progression is just 3. As we continue learning, number 2, let me bring on board our program here for the August holiday. Ladies and gentlemen, you are invited to enroll. It's going to be the best. We have tried our best to come up with the best tutors along across the country. So follow us through 0704153366 so that you ensure that your child has enrolled. Please enroll. Don't be left out. We are the best and we are giving you the best. Reach out for the registration. Number 2, solve the following simultaneous equations: 2x plus y equals to 5 and 5x squared minus 3xy equals to 14. This one is a simultaneous pair of equations, but we can't solve it using elimination method. Definitely, we are supposed to go for substitution, whereby from equation 1, we can express y as 5 minus 2x. Now, it means equation 2 can be rewritten 5x squared minus 3x. Then instead of y, 5 minus 2x. This is equal to 14 that way. So I've expressed equation 1 and rewritten equation 2. So now we can talk about the opening of the brackets there, whereby this is 5x squared minus 15x positive 6x squared equals to 14. Now we can group terms. We start with the 11x squared minus 15x minus 14. This is equal to 0. Yeah, I've brought 14 to the left that way. At this point, we can now talk about a solution. Remember, there are very many methods we can use to solve a quadratic equation. This is quadratic now. So let's get x from this. X equals to, according to the quadratic formula, negative b plus or minus the square root of b squared minus 4ac, then everything divided by 2, the value of a. Substituting in this formula, negative 15 becomes 15 plus or minus square root of 15 squared or negative 15 squared, which is 225 minus 4a, and c is negative 14 that way. So it's 4 by 11 by 14. That one has to become a positive now because of negative 4 times negative 14. Everything is being divided by 2 multiplied by 11. So at this point now we are going to have 15 plus or minus. When I add 225 and 616, I'm getting 841. So I need the square root of 841, which is exactly 29 out of 22. So the possible values of x are, when we take 29 plus 15, then we divide by 22, I'm getting 2. Or I get 15 and I subtract 29, then I divide by 22. This gives me negative 7 out of 11. You see that? So we have the possible values of x. So for y, we will say when x equals to 2, y is going to be, now we substitute 2, 5 minus 2 into 2. This is going to be 1. And we can get another value of x. When x is negative 7 over 11, we can get the different value of y. So we substitute again here for us to get y. 5 minus 2 into negative 7 over 11. And this is going to be 6 and 3 over 11. So we have all the values of x with the corresponding values of y. That's simple. That's simple. Number 3, from errors and approximations. Given that the value of A is 10.0, the value of B, 4.0, the value of C, 5, calculate the percentage error in the calculation of A plus B divided by C. A plus B divided by C. We just find the percentage error. So first of all, we are going to get the limits of all these values. For example, A is going to lie between, they have been, A has been recorded to an accuracy of 1 decimal place. That means we need to calculate from the accuracy, we can calculate the absolute error. When the accuracy is 0.1, the absolute error is when we take the accuracy divided by 2. So 0.1 over 2 is 0.05. So we take 10 and we minus this error. We're getting 9.95 up to 10.05 when we add the error. The same error is found in B. So we'll take 4.0 and we subtract 0.05 to get the minimum possible value, 3.95, all the way to 4.05. Then C has been recorded to an accuracy of our whole decimal, of our whole number, 5. So that means the accuracy in C is 1 unit. If the accuracy is 1 unit, then we can take 1 over 2. That is the absolute error in the recording of C. Then we subtract it to get 4.5. And we add it to get 5.5 as the maximum value. So we have maximum values and minimum values. When you look at the expression here, whose error is being found, you shall discover one thing, that it is a division and there is still some multiplication. So for me to get maximum quotient, from this division, I need the biggest possible numerator. So the biggest possible numerator shall be upper limits added up. Then for me to get maximum quotient, I have to divide by the least possible denominator. And the least possible denominator is 4.5. Up here together there. If quotient has to be maximum, then we need the highest possible numerator and the least possible denominator. So highest possible numerator will be gotten by adding the highest possible values. 10.05 plus 4.05. Then we divide this by 4.5. Ladies and gentlemen, I'm getting 3 and 2 over 15. Let me go to the minimum possible quotient. Now, for me to get a very dismal quotient, I need to talk about the least numerator possible. So I add the lower limits. Then I divide by the highest possible denominator. I divide by the highest possible denominator. What is this giving me? 9.95, and I add 3.95. Then I'm to divide by 5.5. This is 2 and 29 over 5. So we have maximum quotient, minimum quotient, and now we can look at actual quotient or working quotient. Actual quotient. The actual quotient is going to be the quotient of the terms as they have been recorded. 10.0, 4.0, and 5. Just as they have been captured. And this is 2.8. 2.8. So how do we get what we are calling percentage error? We first need absolute error in these computations. Absolute error in the computations. And absolute error shall be, we take maximum minus minimum divide by 2. So absolute error. Maximum minus minimum over 2. 3 and 2 over 15 minus 2 and 29 over 55. Then I divide by 2. Let me work out that, ladies and gentlemen. Just slowly. You don't have to rush. You don't have to rush. I'm getting 10 over 33. This is the absolute error. Then there is something else called relative error, which is given by absolute error divided by working value, or the actual value, 2.8. So I have to divide that. So I divide this by 2.8. This is giving me 25 out of 2, that's 1. Percentage error is usually given by relative error multiplied by 100. So when I multiply this by 100 to make it a percentage, ladies and gentlemen, I'm getting 10.82%. This is now the percentage error in the computation. Yeah, percentage error in that particular computation. That's simple. Number 4. I hope you're following, you guys. Remember, our consultation line is 0704153366. So please reach out for programs through this particular number. Express in surd form and simplify. We simplify the denominator. Or afterwards, we rationalize the denominator. So the first thing that we're going to do at this point is we are going to express the trigonometric ratios of these special angles in surd form. We're going to work with an equilateral triangle, 2 units, 2 units, 2 units, meaning that the angles are 60, 60, 60. Together in that. Now I divide, or I bisect this line such that this becomes 1 unit, this becomes 1 unit, the angle remaining 60, but the one here becoming 30. Meaning that we can now find the height, the perpendicular height. 2 squared minus 1 squared, then the square root. We shall remain with the square root of 3 at that point. That means we can now write 1 minus the cosine of 30. Cosine of that shall be adjacent over hypotenuse. Adjacent is the root of 3 out of hypotenuse 2. Divide by 1 plus the sine of 660. Something else that you're supposed to understand is that, in trigonometry, you've learned angles greater than 360. That is what you're going to analyze. So this angle, which is greater than 360, which possible acute angle shall represent it? The unit circle. Go to the unit circle like that. The first round will give us 360. 360. When we add 90, we shall be at 450. When we add 90 again, we shall be at 540. What about when we add 90 once again? We shall be at 630. So for us to be at 660, we have to continue adding, and we add more 30 here. 30 degrees here. Therefore, the acute angle that we consider now is the one which has been measured from the x-axis. So we consider this 60. In other words, 660, let me work it out here. 660 is equivalent to an acute angle of 60 in the fourth quadrant. Very important to know the quadrant. It is equivalent to a 60 degrees angle in the fourth quadrant. Now that it is in the fourth quadrant, how are signs there? We usually say that all trigonometric ratios are positive, only sines, only tangents, only cosines. So this sign is going to be negative. Signs are negative in this particular quadrant. So we need this one to be equal to negative sine of 60. Negative sine 60, because it is a 60 which is in the fourth quadrant. So the sign has to bear a negative. 1, let me show you now. 1 minus root 3 over 2 divided by 1 plus the negative value of, we talk about sine 60 now. Sine 60 shall be opposite over hypotenuse that way. So now this negative can now disappear. The positive there can now disappear. Yeah, it can now disappear like that. And when you look at this, actually, the answer is going to be exactly 1. The answer is 1 because the numerator is the same as the denominator. Or we can, let's rationalize and confirm whether the answer is 1. When we rationalize, it shall be 1 minus root of 3 over 2 divided by 1 minus root of 3 over 2. Then 1 plus the conjugate now, root of 3 over 2, which has also to multiply the numerator 1 plus 3 over 2 that way. So we are supposed to make the denominator what we call a rational number. So 1 squared minus 3 quarters. Yeah, 1 squared minus 3 quarters to become a quarter. Then up there we will have 1 plus the root of 3 over 2 minus the root of 3 over 2. You know, I'm having 1 times everything. Then now I have to take the root of 3 over 2 times the root of 3 over 2, which is negative 3 over 4 that way. So this part shall cancel with this, and we shall have 1 minus 3 quarters, which is just a quarter. A quarter over a quarter is 1. A quarter of a quarter is 1. A quarter over a quarter is just 1. That way. So it's good to rationalize. It's good to rationalize. Look at number 5. A buyer pays for a car on hire purchase in 15 equal monthly installments. The cash price of the car, of course, was 300,000 Kenya shillings, and the rate charged on compound interest was 15% per annum. A deposit of 75,000 Kenya shillings was paid. Calculate our monthly repayments to the nearest Kenya shillings. Very many instructions. Nearest Kenya shillings. Let's now follow through. It's also good for me to mention to the learners and everybody following my platform. You're supposed to know that when you are acquiring an item on hire purchase, you have to work with a deposit, a cash, and the carrying charge, which is the interest earned on the balance. So let's check the balance. The balance is going to be our principal because it is the amount that will earn interest within the 15 equal monthly installments. So we take 300,000 and we subtract 75,000. This now shall give us, let me check, 300 minus 75. I'm getting 225,000. So this is now the balance after the deposit was made. This balance is the one that shall earn interest. Are we together there? That is what will earn interest. Then what else are we told? So it earned interest until some amount was paid. And according to the compound interest formula, amount will be 1 plus rate over 100 raised to n, the number of interest periods. Therefore, the amount shall be the principal that we are having here into 1 plus rate of interest, 15%. Then in 15 months, we are having 1 year, and 1 year is 12 months, and 3 over 12, which is just a quarter. 1.25 years. 1.25 years. 1.25 years. Because it is 12 months and another 3 months. So 1.25, which is 1.25 hexadecimal. So this will give us what? The amount which will have been earned. In other words, instead of this lady paying cash for the car, she paid a deposit, and instead of the balance of 225,000, she will end up paying a certain amount, which we are about to calculate. Then we multiply this by 225,000. Yeah, so I'm getting 6,267,950,65 Kenya shillings. This is the amount she will end up paying instead of this. So you see there is some interest earned. Then now this amount is being paid in 15 equal installments. So each installment shall be 267,950,65 divided by 15 months, so that we may know per month the much she was giving out. So this is going to be 863.37, whereby when we talk about nearest shilling, it shall just be 17,863. Yeah, 17,863. That is the amount to the nearest shilling, according to the instruction. Look at number 6. Solve the equation 2 the log of 2 the log of x minus 2 equals to, okay, minus the log 2x plus 2 equals to log of x minus 6. Let's apply some laws of indices. We know that n, the log of a, is the same as the log a raised to n. N becomes a power. So the log x minus 2, this one now becomes power 2 minus the log 2x plus 2 equals to the log x minus 6. We apply again the law that says log of a minus the log of b, as long as the bases are the same, and take the logarithm of a, divide by b. So we take the log x minus 2 squared over this one over 2x plus 2 equals to the log x minus 6. At this point, we can agree that now we can drop logarithms to remain with x minus 2 squared equals to x minus 6. This one should be multiplied by x to x plus 2. If that is true, then we need to expand both sides. X squared minus 4x plus 4 equals to, this is 2x squared plus 2x minus 12x. So minus 10x minus 12. That way, after the expansion, we group terms. 2x minus x, we shall have x squared. 2x squared minus x squared. Then negative 10 plus 4, because negative 4 becomes positive on the right-hand side, shall be negative 6x. Then 4 will become positive. It's positive, it shall become negative. Negative 12 minus 4, negative 16. We are now remaining with a 0 here. This is the equation that has to be solved. This is the equation that has to be solved. We can use there are several methods. Let me prefer factorization for once. We work with a product of a times c, that is negative 16 by 1, and a sum of b, negative 6. This could be negative 8 and a positive 2. Yeah, the product negative 16, the sum a negative 6. So now we rewrite the equation such that x squared will have minus 8x plus 2x minus 16 equivalent to 0. We factor out x to remain with x minus 8. We factor out 2 to remain with x minus 8 once again, equals to 0. Yeah. I'm supposed to be very careful to ensure that this is a positive 2 factored out. Positive 2, yeah, to remain with x and a negative 8 that way. From the brackets, we're having x minus 8. Outside the brackets, x plus 2 equals to 0. So x from the first bracket equals to 8. X from the second bracket equals to negative 2. These are the two possible values of x in this particular logarithm function. Number 7. A, 50 degrees south, 20 degrees east, and B, 50 degrees south, 160 west, are 2 points on the Earth's surface. Calculate the shortest distance between A and B to the nearest kilometer, taking pi as 22/7, radius of the Earth, 6370 kilometers. As usual, I advise my learners to sketch information on logarithms, or on longitudes and latitudes. This is 0 degrees equator, 0 degrees prime meridian. Now, on the lower hemisphere, that is the southern hemisphere, we are having 50 degrees in the south. Then 20 degrees in the east. 20 degrees in the east. What are we having here? We are having a place called A. And 160 degrees. 160 degrees in the west. We are having a place that we call B that way. So we are supposed to know this, that when we talk about shortest distance between two places, more so when they are in supplementary longitudes, it is usually the distance across the poles. Now that they are in the southern hemisphere, then it is the distance across the South Pole. If it is the distance across the South Pole, ladies and gentlemen, we are supposed to know that from A, let me check some different ink. From A, we shall pass through the South Pole, then down to B. If they were on the Northern Hemisphere, we would have done the same, but through the Northern Hemisphere. So we go through the Northern Hemisphere. So if this is the equator, 0 degrees equator. Then we are having the South Pole here. Then we are having the other latitude here, 50 degrees in the south, that way. We are saying that there is an angle that we are measuring from the axis of the Earth, there is an angle of 50 here. Then, if this is a point B, there is also a point A here. Look at my analysis very well, please. There is also an angle measured here of 50. For us to go to 50 degrees in the south, we are measuring angles of 50 degrees. Then now our argument is the arc connecting B and C is like this. The arc connecting. So this is the arc from B to A. That is the arc. What will be the angle between here? We are already having 50 and 50. That means we are remaining with 80 degrees that way. 80 degrees that way. 80 degrees that way. So we are now going to pass through a great circle that way, through the South Pole, and we continue to B. From A, we pass through the South Pole, then to B. It's good for you to know, if you are flowing along 20 degrees in the east, and you pass through the poles, you automatically flow through 160 in the west. That is what it means by supplementary longitudes. If you are flowing through 20 degrees in the east, and you pass through the pole, and you continue with the journey, you shall find yourself automatically at 160 in the west. So that's how supplementary longitudes behave. Now, allow me use the space now here and say the distance in kilometers along a great circle is given by theta over 360 2 pi r. So theta is 80 over 360 2 pi r, 6370. 80 by 2 by 2 by 6370, then I divide by 360 and 7. So I'm getting 8897. 8897.78 kilometers. Remember, we've been told to the nearest kilometer. So to the nearest kilometer, then it means 8898. We round off to the nearest whole number. Nearest whole number. That's it. Look at number 8, an interesting question on making the subject of a formula, changing the subject of a formula. Changing the subject of a formula. We get to it. Given that x equals to a quarter, then the square root of tp divided by u, 2u plus p, make p the subject in this formula. The first thing I will do is to do away with the constant by multiplying by 4 both sides. So that this becomes 4x. This becomes the square root of tp out of 2u plus p, that way. Then now I can square both sides. So that this becomes 16x squared equals to tp. Remember to square the constant. Some will say x squared and forget that we are squaring both sides. So on the right hand side, the root sign disappears now. That way. Allow me cross multiply. So that 16 x squared multiplies everything here. That way. So I can have 32 x squared u plus 16 x squared p equals to tp. What are we making the subject? what we are making the subject of the formula is P. So the terms with P can now be pushed to the same side. TP, and we subtract 16 x squared P that way. We have remained with 32 ux squared. So the P can be factored out. P into T minus 16 x squared that way equals to 32 ux squared. Yeah, after factoring out P. So can I remain with P alone now? That 2 out of subject. You just play along with the terms. You play along with the terms. Very simple. Let's look at number 9. A transformation matrix T equals to K, 3, negative K, K minus 2, maps a triangle whose area is 2.5 square centimeters onto a triangle whose area is 50 square centimeters. Find the possible values of K. Possible values of K. That means they might be several. We work them out this way by saying that area scale factor equals to absolute value of determinant. So area scale factor shall be area of the image over area of the object. What are we getting? 50 divided by 2.5, this is 20. The area scale factor is 20. The determinant is 20 or negative 20. So now we'll also say that this 20 now is equal to the determinant of the matrix of this particular transformation. How do we get determinant? Values in the main diagonal multiplied minus values in the other diagonal multiplied. Main diagonal as K and K minus 2 minus 3 and negative K should give us a determinant of 20. K squared minus 2K positive 3K equals to 20. If this is equal to 20, can we group some terms? K squared plus K minus 20 equals to 0. All right. Now we solve this quadratic product, negative 20, sum 1. Is this negative, okay, 5 and negative 4. Yeah. 5 and negative 4. So the equation is written now with K squared plus 5K minus 4K minus 20 equals to 0. We factor out K alone, 1 to remain with K and 5. We factor out 4, negative, to remain with K and a positive 5 equals to 0. So K plus 5 from the brackets and K minus 4 outside the brackets equals to 0. Now we can talk of K equal to negative 5 or K being equal to positive 4. Very simple. You see, the knowledge on quadratic equations is so broad and it's applied in very independent topics. A topic which is not quadratic, you find yourself applying quadratic. So you're supposed to be very careful. Very careful. Number 10 on mixtures. Another interesting area that usually evaluated in the national examinations. A mixture contains 2 grades of rice, A and B, with masses in the ratio 3:5. If the mixture is sold at 270 Kenya shillings per kg, a profit of 20 is realized. Find the cost of 1 kilogram of B if grade A costs 200 per kilogram. So the idea here is to understand that with 270, we are making 20% profit. So 120% is represented by 270. What about the cost without a profit now? The cost of a kg of the mixture. You take 270 by 100 over 120. 270 by 100 over 120. This is 225. So the mixture now costs 225. If it costs 225, then it means we take 3 kilograms according to the ratio, 3 kilograms of A costing A plus 5 kilograms of B costing 200. Find the cost of a kilogram of B if a kilogram of A costs 100. A kilogram of A is known. We are finding that of B, sorry. So we'll say 3 kilograms each at 200 plus 5 kilograms each at unknown. That will be the cost of the mixture. Then per kilogram in the mixture, we divide by the kilograms mixed. The kilograms mixed are 3 and 5. 3 and 5. This one should give us 2, 2, 5. Yeah. 3 kilograms costing 200, 5 kilograms costing B shillings. Then we divide by the number of kilograms mixed, which is 3 and 5. We are supposed to get 225 as the cost of 1 kg in the mixture. So this 600 plus 5B equals to 225 by 8. We get 1800. So 5B equals to 1200 when you subtract there. The value of B shall be 1200 divided by 5, giving us 240. So 1 kilogram of a mixture of B will cost 240. 240. Yeah, 240. Then now we find ourselves in number 11, which is a question on trigonometry. Solve for x given that the tan of 2x plus 30 equals to 0.8391 for negative 180 all the way to positive 180. The first thing that you're supposed to do, we identify an acute angle that we will work with. So the acute angle will be given by tan inverse of 0.8391. So this data that you're working with, 40. It's good for you to remember. It's good for you to remember that the tangent here is positive. So we have to go to the quadrants where tangents are positive. So where tangents are positive, then 2x plus 30 shall be equal to, the first angle is 40, because 40 is in the first quadrant, and there all trigonometric ratios are positive. Then we need another 40 measured in the third quadrant, because tangents are positive in the third quadrant also, and 40 measured in the third quadrant shall be 180 plus 40, which is 240. Then because of the range that we are having, we are going to measure the two angles in the reverse direction. So we take 360 and we subtract 40. We are getting negative 320. We also take 360 and we subtract 220. We are getting negative 140 that way. These are some of the questions that need a lot of understanding on trigonometry. So how do I remain with 2x? I have to subtract 30 from all of them. 10, 180, is it 180? 220 minus 30, yeah, 190, not 180. Then negative 320 minus 30, giving us negative 350. Negative 140 minus 30, negative 170, that way. So x shall be, when we divide by the 2 itself now, 5, 190 over 2, 95, 350 over 2, negative 175, 170 over 2, negative 85. So if we are to arrange them in order, x shall be equal to negative 175, negative 85, 585, according to the provided range. So these are the 4 angles, depending on the range which has been provided. Number 12. In the figure below, AD is the diameter of the circle with center O. TCS is a tangent to the circle, let's see, as we can see, and the angle CAD is 48, just as indicated. Find the size of angle ACT. ACT, and give a reason to your answer. So we're supposed to know one thing, that because AD is a diameter, then angles subtended to the circumference of a circle by diameter are usually right-angled. So we take 90 minus 48, and we shall discover that the angle at this point is 42. That angle is 42. If that angle is 42, then, ladies and gentlemen, I have to conclude that now ACT as an angle equals to also 42. The reason being, angle made by a tangent and a chord equals to angle subtended by the same chord in the alternate segment. In the alternate segment. So if a chord like ST makes an angle with a tangent, a tangent ST is making an angle with chord AC. The angle is here. This angle will be equal to the angle subtended by the same chord AC in the alternate segment, that is at point D. So the angle of 42 will also be at C. Those angles are usually equal. That is from 3 work. Please ensure that you revisit all the properties within angles. Let's look at number 13. A very good question. Expand and hence find the constant term in the binomial expansion. 2x minus 1 over x raised to power 4. First, we can get what we are calling the binomial coefficients. For power 2, they are 1, 2, 1. For 3, they are 1, 3, 3, 1. And for 4, 1, 4, 6, 4, 1. So now we are expanding with binomial coefficients of 1, 4, 6. Let me space them out very well. 6, 4, 1, that way. For power 4, these are the binomial coefficients. The first term shall be 2x raised to power 4 and negative 1 over x raised to 0. In the next term, 2 power x goes to power 3, but negative 1 over x ascends to power 1. In the next term, 2 power x descends to power 2, as negative 1 over x becomes now squared. Then 2x raises or goes down to power 1 as negative 1 over x takes power 3. Then finally, we shall talk about 2x taking a power 0 and negative 1 over x, assuming the full power 4. These are binomial expansions. From the first term, 2 power 4 is 16. X power 4, that way. Remember, anything power 0 is just 1. So negative 1 over x power 0 becomes 1. Then we will have minus 2 power 3 is 8. 8 times 4 is 32. X is power 3, but now we are multiplying again by x. Because negative 1 over x raised to 1 remains the way it is. That's why we are starting with a negative, actually. So the x there will cancel 1x. And instead of power 3, it becomes power 2. Plus, the other term shall be 2 power 4. 2 power 2 is 4. Then times 6 is 24. X is squared. And in the other side, when we square negative 1 over x, it also becomes 1 over x squared. So x squared in the denominator and another x squared in the numerator now cancels. And that way we will get just 24. The next one shall be this one. We start with a negative, of course. We are starting with a negative because negative 1 over 3. Negative 1 over x power 3 becomes negative 1 over x power 3. So we start with a negative. Then we talk of 2 power 1, which is just 2. That gives us 8. We have x. Then on the denominator, we have x power 3. So 1x cancels, and at the denominator, we remain with x squared. So we can bring it on top, and it becomes minus. According to the laws of indices, that's not a mistake. Instead of 8 over x squared, the x can also come up, and the power becomes negative. Yeah, the power becomes negative. That way. Finally, what are we adding? 2 power 0 becomes 1. So negative 1 over x shall become positive 1 over x power 4. And the x power 4 can go up and possess a negative power. When you look at all this, the constant term is the term that is not having the variable. The variable here is x. Any term without x is only 24. So this is the constant term in the binomial expansion. That's what it means by constant. The position vectors OM and ON are 3i minus 6k and 12i plus 6j minus 9k, respectively. Given that Q divides Mn in the ratio 1:4 externally, find the vector Q M in terms of I, J, and K. Let's first find the position vector Q using the ratio theorem. So we are having position of M, position of N, and position of Q. Now, because Q is an external divider, it cannot be between M and N. It is just an external point. So the ratio from M to where Q is should be 1. Then going back to N, we need 4 units. We need 4 units. In other words, externally in the ratio 1:4 can be written as 1:4. And what does it mean? You see, the second proportion is bigger than the first one. If the second proportion is bigger than the first one, then it means this is how they are arranged. I want to write them very well for you to understand. Q is the one dividing Mn. So from M to Q, from M to Q, we have 1 unit. And from Q to N, we have 3 units backwards. 3 units backwards. We move 3 units backwards so that we may get N. That means we are going beyond M. So that means there is 1 unit and 2 more units here. In other words, now, M is between N and Q, such that we are having 2, 1 as the ratio in which M divides NQ. So now the vector Q is known. This is the vector at N is known as 12, 6, -9. And M is also known as 3, 0, -6. 3, 0, -6. Yet this one is not known, X, Y, Z. So we usually say the coordinate of M, 3, 0, -6, is equal to the first ratio of 2 out of all the proportions 3 into X, Y, Z plus 1 out of the total proportion, that's a third, times the opposite vector to that. Yeah, that way. I'm going to use the space, even the one below. So let me use the right-hand side as first. 3, 0, -6 equals to 2/3 X, 2/3 Y, 2/3 Z, plus, when you multiply by a third, 4, 2, -3. 4, 2, -3. Yeah, 4, 2, -3. So how do I remain with 2/3x? It shall be 2/3x equals to 3 minus 4. That is -1/4. So I have to multiply this by -1, that is, multiply by 3/2. So I'm getting -0.75. Yeah, I think I should have done the right thing there. Look at this carefully. When I say I want to remain with 2/3 X, then I should have, because I'm dealing with the X components first, X components. So it shall be 3 minus 4, which is -1. -1. So how do I get the X itself now? X shall be -1 times 3/2, which is -1.5. What about the Y? 0, okay, 2/3 Y equals to 0 minus 2, which is a -2. So Y equals to -2 times 3/2, which is -3. What about Z? For me to get Z, now I'm supposed to use the Z components. 2/3x equals to -6 plus 3. Because 3 is negative, it has to become positive. So how do we get the Z itself now, not X? So Z shall be -3 times 3/2, giving us -4.5. So the position vector of Q, shall be X, which is -1.5 I, plus Y is a -3. So this is a -3J minus 4.5 Z. That is the position of vector Q. But what was the question? Vector MQ. vector MQ. So let's look at vector MQ. For us to get vector MQ, ladies and gentlemen, for us to get vector MQ, we are supposed to talk about what? Q minus M. That way. Then I subtract M. QM vector MQ. Yeah, I take Q minus M. So M is 3, 0, negative 6. This now shall be negative 4.5, negative 3, and we are having a plus 6 now, so 1.5. 1.5. Therefore, when we are talking about vector MQ, it shall be negative 4.5i minus 3j plus 1.5k. That is the vector the examiner wanted students to solve. Yeah, that is it. Let's check number 15, ladies and gentlemen, from circles. Graphical work, visions of a circle. How do we solve this one? How do we solve this one? Very quickly, we are going to find the solution. Very quickly, we find the solution. Find the solution. Okay, so the solution shall be, we are already having the terms for x, so we are supposed to ensure that the squared part equals to 1. So when we divide through by 2, it shall be x squared plus 4x. I have to add a constant here to make it a perfect square. Then this is y squared plus also a constant, then equals to 10 becomes positive, but remember it's also being divided by 2. It becomes positive and it is also being divided by 2 because we are dividing the whole function by 2. So now to complete the square on the part of x, I need 4 over 2 squared. 4 over 2 squared is still 4. X squared plus 4x plus 4 that way, plus y squared. Here we just add a 0 equals to 5 plus 4, which is a 9. 5 plus 4, which is a 9. So if I expand this part, I'll be having x plus 2 squared, then plus y plus a 0 squared. That's why we are not having anything there. That's why we are not having any other term with y equals to 9. This is now the general equation of a straight, of a circle. General equation of a circle. So if this is the general equation of a circle, ladies and gentlemen, we can find the center. Actually, we can just extract the center, which shall be, the center shall be negative 2 for x and a 0 for y. And the radius shall be the square root of 9, which is just 3. Yeah, the square root of 9, which is just 3. That's simple. We talk about number 16 now. The gradient function of a curve is given by dy dx equals to 3x squared minus 8x plus 2. The curve passes through 2, negative 2. Find its equation. One thing that you're supposed to understand in this case is that, we are having the equation for the gradient function. That means this is the differentiated equation. To get back to the function itself, which has been differentiated, now y will be given by, we integrate. We now integrate with respect to x. We integrate with respect to x. That way, let's integrate. Y shall be x power 2 becomes x power 3, and the 3 divides. So that's just x power 3 minus x becomes now power 2, and the 2 divides. So that this becomes 4 plus 2 x is introduced. Then we call it arbitrary constant of integration that way. So this is the general equation of this particular curve. And for this particular curve, there is something that we are supposed to know. The thing that we're supposed to know is that according to the provided coordinate, it means when the value of y is -2, x is 2. So we can substitute here so that we may know the arbitrary constant. -2 equals to 2 power 3 minus 4 into 2 squared plus 2 into 2. Instead of x, we're having 2 plus c. So -2 equals to, let me work out this part. 2 power 3 is 8 minus 4 into 2 squared plus 2 into 2, which is a 4. So I'm getting -4 plus c. And how do I remain with c? By taking 4 to the left, where it becomes positive, minus 2 plus 4, which is just a 2. So the equation now that we have known the constant, shall be x power 3 minus 4x squared plus 2x plus 2. This is now the specific equation for the particular curve. Thank you so much for following. Remember to follow our program here for the August holidays and get the best from the best. Subscribe and share.